Howdy again, Mr. Pete here, your YouTube shop teacher, and this is tips number 1003, which is the 10th or 11th in this series, but I'm calling this part B because there was a part A where I made the pattern and the casting so that I can machine a faceplate for the little 6-inch Atlas Craftsman number 618 lathe. I hope you've watched all of the videos, so this is the latest project. You might find it of interest, and of course no one will need to do this, but there are a lot of different operations and interesting things here, I think, for you to enjoy and watch, so stick with me as we begin here. Most of you out there know that I am a man that wears both suspenders and a belt. I don't take any chances. So I made an extra casting just in case, in the unlikely event that I ruin this one. And notice that I put the riser right in the middle this time. Absolutely no shrinkage, that's what it's all about. There was no shrinkage here either. And this is a little bit more material than I need, so this will be machined off, so there's no problem there. Now this one, I made it by a little bit different method, so I didn't end up with a good finish here. You can see where I screeded it, but that doesn't really matter because that part will be machined anyway. I'm not sure if I will machine this surface. Depends on how true it runs. And I think I mentioned earlier that I don't believe this machine is capable of what I need to do. So I need to drill a hole that is what, 7/8, and then I need to tap it. Well, that can't be done on this machine. And even after I get the hole threaded, if I were to screw it on the spindle thread here, would this machine have the power and the ability to allow me to turn and face a large diameter? That would be very questionable, even though it's aluminum. So I don't intend to do that. And also remember that I will be threading this 1" 8, and that is not a real common thread for these machines. Most of them were 10 threads per inch. I still do not understand that all, and that is a common national course thread, number 1" 8, so I have a tap for that. I do not intend to do single point threading. All right, now that you got a general idea of what I'm going to do, let's go on down into the other shop, and all of this machining will be done on my clawsing lathe. And the reason for that is it's a larger lathe, and I prefer that for this type of project because it's easier for me to photograph using that lathe. I can get the camera in from all different angles, and I have good lighting and all of that down there. So this will probably be a long video, so bear with me. A lot of fun things to do. I hope you're enjoying working in your shop as much as I enjoy doing this. All right, let's get started here, and I intend to use number 1. This is my backup, but let's talk a little bit about castings. First of all patterns are tapered. That's called draft, so this surface here is not square. And as you can see, so sometimes that's problematic in holding it in a chuck or a work holding device. I don't think it will be here, but just take that into consideration. Secondly, all castings shrink. So normally we start with a pattern that is larger than what we need by what, 5–10% or whatever. I think it's 5/32 per inch of shrinkage in aluminum. So let me show you what I'm talking about. So there is pretty much the rough dimension of the wooden pattern, 5.7, and on a casting now, a rough casting, notice that it is smaller. It shrunk when it cooled, so it's from 527 down to 563. So there's a little bit of shrinkage there, not a whole lot to worry about, but that sometimes has to be taken into consideration. But not in this case, because it could matter less. If this would be 3 inches or 3 1/8. So this is the one I'm going to use. Let's go ahead and put it in the 3-jaw chuck of the closing. I've already reversed the jaws to save you the boredom and pain of watching me do that. So when setting this into the reverse jaws here, I push it in as hard as I can, I snug the chuck, and then I like to tap it to make sure that the casting is truly in contact with the back of the jaws and does not wobble. Pretty important. I almost forgot to tell you this, but the dimension here between my fingers needs to be about 1 1/8, and of course I made this larger, which makes this larger, so when I take the Lufkin caliper and I measure right there, I know it's a rough measurement, but I end up with about 1 1/4, so there's plenty of material here to face off. And a little bit will be faced off on that side, I would suppose. When I set the work up in the 3-jaw here, I was hoping that the hub would be pretty true or concentric, but I didn't expect it to be, because remember, I just rough sanded the pattern, so I knew that it wasn't truly round. So I've got an indicator on the hub, and I know I'm coming in there at an angle, and we got inaccuracies, but it's close enough for what we're doing here. So with the indicator on 0 there, you can see that other than a little fluctuation there, it's running pretty true. And why am I concerned about that? Because initially I wasn't really planning on machining the hub, and I love the looks of the fillet in there, but I'm afraid I will have to machine that off for it to run true and not wobble or vibrate, although I don't think it'll vibrate on that little lathe. But you can see that they did turn it down on a commercially made one. However, they left a little bit of their fillet there. So that, I think that's kind of interesting, isn't it? All right, back to the machine. Okay, I'm going to take a cleanup cut here and see what it looks like. Okay, that tool's going to work just fine. Now some scenes will be sped up. For those of you who are wondering why I put that bodacious countersink in there, and in fact I was going to do it on both sides but didn't, and that was all about trying to reduce the mass or the volume of metal to minimize shrinkage, but using that was my backup method. My that big old riser did the job. I mean, there wasn't a bit of sinkholes now. You know, there's 2 different kinds of shrinkage. I'm talking about sinkholes on thick portions of a casting. I'm going to drill the hole and tap it and bore it and all of those good operations before I face this, just in case this ends up being a failure. You never know. Maybe I'll have to go back and single point it, because I'm not used to tapping real large holes, but I know that'll take a lot of torque. But procedure here will be a big old center drill, a 1/4 inch, a 1/2 inch, and then the tap drill size needs to be 7/8, but I'm going to drill 13/64 and bore it 7/8 so that I can make sure that the hole is trued up before I run the tap in there. And then there's also a bit of a counter bore that I need to bore in here, and you'll see that in a minute. If you like this kind of video, please give me a thumbs up or leave a comment. It helps me an awful lot. And now 1/2 inch. 13/16. In keeping with my policy of wearing suspenders in a belt, I have checked it with a telescoping gauge, and I creep up on it. Creep up on it! Don't be too bold. And there's my 7/8 plug. You know, I'm just going to thread that hole anyway. It doesn't probably need to be that accurate. And a 7/8 reamer By the way, this is a Cleveland trademark on there. Make sure you watch one of A-Bomb's latest videos where he visits Cleveland and watches them make taps and drills and end mills. You will love it. Look it up. Search for it. Anyway, that's ready to tap, but remember I also have a step, an undercut that'll be 1 inch and I don't know, quarter. I got to measure how long that will be, and then I'm ready to tap. I'm just about ready to thread this hole, but I wanted a bolt, a thread to check it with. And you know, I had one nut. I had this in stock, and I only had the one nut. You know, I had a friend that only had one. That was Johnny that went on that big boat trip with us. Isn't that something? One was undescended. Oh, never mind. Hope you didn't understand that. So anyway, I bought a 1 inch coarse bolt. Now it's a grade 5. I didn't care what grade it was. And here's the chuck. And it does fit. You see, I want to use this as a plug gauge. Even though it won't be very accurate, I mean, I'm sure that the tolerances on this aren't that great. But just take a guess what that bolt cost. And when the kid pulled it out of the cab, I said, let me guess. I said $279. And he said, wrong. $549 for one bolt. Now that means that I have well over $1.5 million worth of fasteners in this house. It's just that I don't have very many large ones. I know that's a little bit off topic, but I'm so cheap and I'm not going to do any damage to this. I actually am going to return this one tomorrow because I saved the tag in there, the receipt, and the girl said, yeah, bring it back if it doesn't work. All right, that was irrelevant. But I have one more step. I need to counterbore. Can you see that this has been counterbored? And I think you saw the thread on the machine a little while ago. And I made, again, a 1 inch plug gauge to check that out. And this is 5/16 deep. That'll also give me a little bit of a pilot or a head start when I go to thread it. So I will do that before I thread. This may not be worth showing you, but I want to counterbore 5/16 deep, so I'm bringing my boring bar in so it touches. And then I have my carriage stop right here, and I will take a 5/16 square tool bit, but you could use a drill bit too, just the shank on a drill bit, and draw that up against, lock it, and you have then very accurately set your carriage stop for boring or whatever the process or operation may be. Okay. Okay, the counter bore is perfect, but as far as using this big old bolt here as a gauge, it's only going to be semi-accurate. And I've noticed this before. You know, they roll these threads on. They don't cut them on, but I'm miking it, and it's really 10/1000ths under. I'm not surprised. I kind of expected that because this isn't a high-quality bolt. I was like, you know, it's just a common bolt, not a cap screw or anything of that nature, and they're made with pretty loose tolerances. The machine isn't back here to lock the spindle. I'm supporting the tap with a live center, and I'm using a 12-inch adjustable wrench, and I doubt that I will have the leverage that I need, but let's see what happens here. Well, I had to bring in the militia with my 15-inch wrench. If this had been steel or cast iron, I would not have had the strength to tap it. I would have to use a single point threading tool on a boring bar, but if I had to do that, my MO would be to go ahead and thread it to the maybe 3/4 of the depth with the boring bar, which is a pain in the neck, and finish it off with the tap, and then it would be fairly easy going. Now, I know this is going to go in easily because of what I told you a few minutes ago, that it's 10 thousandths under. So that's all there is to that. I'm returning that to Ace Hardware. I'm trading it in for a paintbrush because I need to paint some windows around this joint. You know, I worry about things. You know, I was worrying that I couldn't do this. I was worrying about this and that. And now I'm worried about, I know it fit on that bolt, but will it truly fit on the spindle of the machine? But I'm not going to take this off at this time because I would never get it back in here, because now I want to face this. But in fact, I've been working at this for 4.5 hours, and at supper time, I'm quitting for the day. I need to have a little bit of a rest. But I just mentioned worrying about things. You know, a lot of things I don't worry about anymore. I don't watch news, so a lot of things I don't know what's going on, thank goodness. But I used to be worried about nuclear attack. I don't think about that anymore. I could care, well, I don't want it to happen, but in 1962, I think it was during the Bay of Pigs invasion, the machinist, when I worked at Monarch Electric, said, you know, Lyle, tonight you better sleep with your German Luger under your bed, under your pillow. And he scared the heck out of me. But of course, nothing happened. And, you know, he cried wolf. People have cried wolf too many times. All right, I'll see you tomorrow. All right, it's the next day, and I've got a lot of work to do yet on this project, and we're already 20 minutes, I think, into the video. So I was just wondering how much run out here that I had on the casting. I know that I need to face it, but I was just curious as to how much run out there is. So let me zoom in on the indicator and check it out. Okay, the indicator tip is up against the casting, and I have zeroed it out, as you can see, and in turning it 1 revolution, I am about 10 thousandths total indicator run out. That is way too much to ignore. This surface must be faced, so that's our next step. Well, using this tool, I hope to be able to clean up the hub and then face it off without moving the tool, but I don't know if that's possible, so let's give it a try. Well, it didn't quite clean up yet, but a couple more passes off camera and the job will be done. It's kind of a chattery finish there, so I might have to change tools or inserts. Well, I did switch tools, and I think I can both turn and face with this one, and I'll show just a little bit of that. Boy, that looks pretty good. It cleaned up nice, didn't it? Little bit of imperfection right there that could matter less. I'll put a nice chamfer on the corner here, and then I'm really done with this side. Okay, out of the chuck it comes, and we go into the other shop and see if this actually fits on the spindle. Cross your fingers. It looks pretty darn good, doesn't it? Of course, now we got the periphery to turn, and we need to face the side, and we need to put slots in it. I'm very nervous. I have not tried this yet because there is no chance to put this back into the closing lathe and true it up or whatever. I'd have to start over. So drum roll, if you please. Will it fit? By gosh. And it goes all the way up to the shoulder. Wow, I'm loving it. So that's pretty much how it will look, other than the 2 slots. And of course it's not running true. It has to be turned down and faced. I want to take it down to 5 1/4. And you know, originally I thought, I believe I'll just turn this on this machine to see if this machine is capable of it. But since there's no power feed for doing this, and I could not get the tool way out here to turn the periphery, so I'm just going to do it downstairs on the closing. Well, it would be so much better to be able to turn this on the thread of the machine where it's going to be used. But as I said, the closing, and what I'm going to attempt to do here is to grip it with the 3-jaw on the hub. Now that will not run all that true, but I'll take it down to diameter for 5 1/4 and then face this off. And when I put it back on the Atlas machine, I will check it with the indicator to see how much run out there is. But you know, it doesn't really matter. I wouldn't have to machine that at all, because remember, all we're doing is driving work between centers with a dog. But yet a fella has his he has his pride. A terrible thing, by the way. Pride's a terrible thing. Well, I had to reverse the jaws again, and that was 10 minutes of misery. But again, I'm chucking by the hub, and it probably will leave some marks on the hub, which I do not like the idea of. So I'll snug that down real well, and the first thing I believe I'm going to do is to turn it to diameter, which is around 5 1/4. Okay, the calipers is set for 5 1/4. Remember, I can use this while the machine is running, but it looks like I have, what, about almost 1/4 of an inch to take off, so I won't show all of it, of course, but hope you enjoy this. Okay, I think I'm there. Let's see what we got. And I'm right on, and I can double check it with all kinds of other instruments, and it's just fine. So now I need to face off the front. I switched tools, so I'm using an insert with a slightly larger radius for a better finish. Let's see what happens. Hopefully this is the final pass. I have switched to a different tool, and this insert has a much larger radius because I'm not satisfied with that surface finish at all. Okay, that finish is too good to be true. So now I'm going to change tools and put a little bit of a chamfer here. The faceplate has been died and clamped to an angle plate, and I'm going to use the height gauge now and draw a center line, which I've already calculated. And yes, I am not on granite surface plate, I'm just on the bench top, but it's good enough. Clamp was in the way. So that's the center line, and now I will reset the height gauge. The slot is going to be 7/16 wide, so I'm going to set the gauge here for 218 above the line and 218 below the line. This is above the center line, and now below the center line. See how nice that works? Well, it's all laid out ready to mill 7/16, and one of these slots, there'll just be 2 slots. One will go all the way through like this, and the other one partial, as you can see here. And I'm going by the diameter of these smaller dog tails, so I think 7/16 will work. just fine. If not, I will modify it later. But these are 1/2 inch wide in this bigger one, so there we go. Alright, I'm finally ready to mill the slots with a 7/16 end mill. Get a look at the setup here. Now the clamps are already tightened, but I located it using a combination square and all these parallels and everything, and I have that center line which you saw me lay out a few minutes ago, and I'm using the square, and I rotated the work until the square lines up with the center line, and then I tightened those 2 yellow clamps. And there's an alternate way of doing it. Well, I'm pretty sure you can't see that center line, but you can use a wiggler with the point, and I've already centered it nicely, the wiggler that is, and I'm right on the line, and I'm going to come down to this end and also make sure I'm on the center line. It's probably a little more fiddly, but that's a good way of clamping it down. Now, why are the 4 holes drilled in there? Because when I use this type of end mill, a 4-fluter, it doesn't cut on the very center, and those are like relief holes, optional of course. And away we go. And the second slot. And I believe the project is done except for a little deburring and maybe remove the layout die. It was a long video, wasn't it? And there it is. Well, there you go. The pattern, the rough casting, and the finished machine casting, all ready to go. Let's go on out to the Atlas and put it on there and see if it fits and take a picture of it. There it is. And a dog, of course, will fit in there like that on the work. And I'll be doing that soon in another video where I machine a commutator. So be sure and watch for that. I hope you enjoyed the video. I know it was a long one, and it took 2 days to do this project. So thank you for watching, and please give me a thumbs up and leave a comment if you're in the mood. So long for now.